Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 12, question number 13, and question number 14 of exercise 4A ICSE 9th Physics. The chapter name happens to be Pressure in Fluids and Atmospheric Pressure. The previous questions have been done in the previous videos, the link for which will be provided in the description below. Do check them out if you have not seen them by now. If you happen to like the video, do share it with your friends and consider subscribing to the channel. So let us start with the 12th question. A force of 50 kgf is applied to the smaller piston of hydraulic machine. So 50 kgf is applied in the smaller piston, neglecting friction as we do it in all the other problems. Find the force exerted on the larger piston if diameter of the piston are 5 centimeter and 25 centimeter respectively. If you have followed the previous videos, you would have seen from last 5 or 6 problems, we are doing the same type of sums. In this, the diameter is given, that is, the diameter is given to be 5 centimeter for the smaller piston and 25 centimeter for the larger piston. Force on the smaller piston is given as 50 kgf. When we convert kgf to newtons, we multiply by 10. So 50 into 10 gives me 500 newtons. So the force happens to be 500 newtons. So for finding the area of cross section, we will be using the formula, since it is circle, we'll be using the formula pi r square. So A1 happens to be for the smaller piston, so pi into R1 square, where R1 is the radius for the smaller piston. Now in the question, we do not have the radius for the smaller piston, we have the diameter. So I write this formula in terms of diameter, that happens to be pi into d1 by 2 the whole square. This can be written as pi into d1 square by 4, because 2 square is 4 and d1 square is d1 square only. So pi d1 square by 4. Now I substitute the value of d1 as 5 into 10 to the power of minus 2. Now where did this minus 2 come from? As you can see here, the diameter is given in centimeter, and centimeter is not the SI unit. So in order to convert it to SI unit, that is to convert from centimeter to meter, I multiply by 10 to the power of minus 2. If you have any doubts regarding the conversion from centimeter to meter, or centimeter square to meter square, or millimeter square to meter square, I have clearly explained that in the first video of this exercise. Do check that out if you have still not seen that. So pi into 5 into 10 to the power of minus 2 the whole square divided by 4. So d1 is substituted as 5 into 10 to the power of minus 2. So I would be keeping this. There's no point in solving this here because we would be wasting time if we solve this here. I would be carrying it as it is. Force on the larger piston we need to find. So F2 is a question mark. A2, that is area of cross section for the larger piston, will again be pi into R2 square. Now R2 can be written as d2 by 2. So pi into d2 by 2 the whole square. That happens to be pi d2 square by 4. Now d2 I substitute it as 25 into 10 to the power of minus 2. Again 10 to the power of minus 2 came since I am converting from centimeter to meter. So I get 25 into 10 to the power of minus 2 the whole square divided by 4. So that is what is A2. Now we would be writing the Pascal's law, that is pressure on large piston will be equal to pressure on small piston. So we can write F2 by A2 is equal to F1 by A1. We need to find the force on the larger piston. That means we need to find F2. So A2 goes to the other side and we get F1 by A1 into A2. Now I would be substituting the values. Be really careful when we are substituting the values. So F1 is 50 kgf, that is 500 newtons, divided by A1 here is pi into 5 into 10 to the power of minus 2 the whole square divided by 4. We got it here, into A2 is pi into 25 into 10 to the power of minus 2 the whole square by 4. So I've written this as it is. Now this would get inverted and this would go to the numerator. So next step, I write this 4 will go up. So 4 into 500 remains as it is, into pi into 25 square is 625, into 10 to the power of minus 2 square is 10 to the power of minus 4, divided by, we have the pi as it is, into 5 square is 25, into 10 to the power of minus 2 whole square is minus 4, into 4 remains as it is. Now I would be cancelling whatever we can cancel. 4 and 4 would cancel. 10 to the power of minus 4, 10 to the power of minus 4 would cancel. And 25 into 20 times will give me 500. So we are left with 20, pi and pi also cancels. So we are left with 20 into 625, which happens to be 12,500 Newton, or we can write it as 1250 kgf. Remember, 1 kgf is 10 newtons. So 1 newton will be 1 by 10 kgf. So we divide this by 10 and we get it as 1250 kgf. Now in this video, I would be solving the next question, that is question number 13 at the end. And here I would be doing question number 14. So the 13th question will be followed by the 14th question in the later half of the video. So starting with the 14th question, what force is applied on a piston of area of cross section 2 centimeter square? Now area of cross section is given as 2 centimeter square. This is the smaller piston probably, to obtain a force of 150 Newton on a piston of area of cross section 12 centimeter square. Yeah, so this is the larger piston, area of cross section 12 centimeter square. Smaller piston, area of cross section 2 centimeter square. Force on the larger piston 150 newtons. Force on the smaller piston we need to find out. So A1 is equal to 2 centimeter square. Now centimeter square, whenever we convert to meter square, we multiply by 10 to the power of minus 4. Again, I am repeating, if there is any issues with understanding this, do check out the first video of this series. So 2 into 10 to the power of minus 4 meter square, and A2 is 12 centimeter square. Again, I multiply by 10 to the power of minus 4, since I am converting from centimeter square to meter square. So 12 into 10 to the power of minus 4 meter square. Now the same formula as we have been using from almost all the sums of this exercise, that is F1 by A1 is equal to F2 by A2. F1 we need to find out, that is force on the smaller piston we need to find out. A1 goes to the other side, we get F2 by A2 into A1. Now we just need to substitute the values. F2 is 150 newtons as it is given here, divided by A2 is 12 into 10 to the power of minus 4 into A1 is 2 into 10 to the power of minus 4. 10 to the power of minus 4, 10 to the power of minus 4 cancels. And after solving this, we get it as 25 Newton. So the force on the smaller piston is 25 Newton and the force on the larger piston is 150 Newton as that is given in the question. Now going ahead with the 13th question, this happens to be the last question for this exercise. The 13th question is usually repeated in the exams, so do pay some attention for this. Two cylindrical vessels fitted with pistons A and B of area of cross section 8 centimeter square and 320 centimeter square. So we can say that the smaller piston has an area of cross section of 8 centimeter square. The larger one, that is B, has a area of cross section of 320 centimeter square. Are joined at their bottom by a tube and they are completely filled with water. When a mass of 4 kg is placed on a piston A, so that means 4 kg is placed on piston, a smaller piston. Find the pressure on piston A. First thing, remember we have the mass here, so we need to convert this. So as of now, we write the area 1, that is area of smaller piston, that is 8 centimeter square. Now centimeter square to meter square, we need to multiply by 10 to the power of minus 4. So 8 centimeter square can be written as 8 into 10 to the power of minus 4 meter square. A2 happens to be 320 centimeter square. Now 320 centimeter square, whenever we convert to meter square, it happens to be 320 into 10 to the power of minus 4 meter square. Now we need to find the weight on piston A. So for finding the weight on piston A, we'll be using M into G formula, because weight formula is mass into acceleration due to gravity. You have learned this in the previous chapter, that is F is equal to M into A and W is equal to M into G. So here, since we are finding weight, we'll be using W is equal to M into G, where small letter g is acceleration due to gravity and small letter m is mass. Mass is given to be 4 kg in the question. So I write it as 4 into acceleration due to gravity. I assume it as 10 meter per second square. 4 into 10 gives me 40 newtons. So weight on piston A happens to be 40 newtons. Now we need to find the pressure on piston A. Pressure on piston A will be F1 divided by A1. F1 we got it as 40 Newton, and A1 is given in the question as 8 centimeter square, which happens to be 8 into 10 to the power of minus 4 meter square. So we get it as 40 divided by 8 into 10 to the power of minus 4. 10 to the power of minus 4 goes to the numerator, becomes 10 to the power plus 4. 8 into 5 times is 40, so we get 5 into 10 to the power of 4 pascals. So this is the first part of the question. Coming to the second part of the question, the pressure on piston B. Now, as Pascal's law says, pressure on piston A will be equal to pressure on piston B. So that would be 5 into 10 to the power of 4 pascals only. The pressure would not change. Now next thing we need to find is thrust on piston B. So again we'll be doing pressure is equal to force by area, or you can call it as thrust by area. Thrust is nothing but a force which is acting in the downward direction. So please remember, don't confuse. Don't think that thrust and force are totally different. Force can actually exist in any direction, but thrust has to be either downwards or upwards. If it is upwards, it is called as upthrust. If it is downwards, it is just called as thrust. So F2 will be equal to pressure into A2. So pressure, we just got it as 5 into 10 to the power of 4 into A2, that is area of the bigger vessel, the bigger piston, that is 320 into 10 to the power of minus 4 meter square. So we get it as 5 into 10 to the power of plus 4 into 320 into 10 to the power of minus 4. 10 to the power of plus 4, 10 to the power of minus 4 cancels. So we have 5 into 320, which gives us 1600 newtons. So the thrust on piston B is 1600 newtons. So this completes all the questions of this particular exercise. See you guys in another video of some other exercise. Till then, goodbye and do subscribe to the channel. Dhanyavad.